Today I'm going to talk about section 8.4, and really the only difference between 8.4 and 8.3 is there's a number that's in front of our x squared term. So basically quadratics in the generic form look like this: ax squared plus bx plus c. And a, b, and c are all just numbers. So in the example that we've got, a is 2, b is 15, c is 27. Everything in section 8.3 had a as 1, or something that looked like this: x squared plus 5x plus 6. We would look for two numbers that multiply to give me 6 and add to give me 5. And it was pretty simple. So we would do x plus 2 times x plus 3. And if we FOILed that out, we would get what we started with. So we factored it into those two factors. And today, since a is no longer 1, we'll have numbers like 2 or anything else out in front of x squared. It's going to make things a little bit more difficult. So there's kind of two routes you can go here. You can go the guess and check route, or you can go a direct route. First, I'll show you what it looks like to guess and check. So if I'm looking at what we're going to come up with, I know that my two first terms have to multiply to give me 2x. Well, there's only two factors of 2 that I can use. That would be 2 and 1. So it's got to be 2x times 1x, or just x. And I'm just going to put x. So 2x times x does give me the 2x squared. I also need my two last terms to multiply to give me 27. So we got to look at the factors of 27. So 27 and 1, or 9 and 3. Now the 2 in our problem here is going to make things a little bit more tricky. So we're no longer looking for two factors of 27 that add to give me 15. We're looking for two factors of 27 that that with that 2 will also add to give me 15. So there's an extra little multiplication that comes in here and makes things a little bit more interesting. So we can guess and check, and you can kind of educate a guess and check, because no matter where I put 27, if I were to use that, it's not going to come out very nicely. We're going to get numbers that are way too big to add to 15. We're already going to be above 15 if I use 27. So we can safely pretty much cancel those out. So then with the 9 and the 3, we just have to put those in the right spots. So let's say that you thought the 9 went here and the 6 goes here. Or, sorry, 3. There we go. 9 times 3 does give me the 27, which is good. But what then we need to check is, does 2x times 3, which is 6x, and 9 times x, do those add to give me 15x? They do. So we actually put them in the right spot the first try here. So basically what you're doing there with the guess and check is you put them in the spots that you think they're supposed to go, and then you FOIL it to see if you get the same thing. If I would have put the 3 and the 9 in opposite spots, it wouldn't have worked out. Okay, so that's guess and check. Now the direct way is a little bit different, and sometimes you're not going to want to use the direct route because it can get you can get really big numbers to work with, and it can just be more confusing. And in the future, I'll show you different ways to factor other than this. So anyway, here's a little trick we can do. We can do 2 times 27, which is 54. And we can look for factors of 54 that add to give me 15. So 9 and 6 are two obvious ones. So what I'm going to do is I'm going to replace 15x with, actually we're going to go 6x plus 9x. Still equals 15x. And then we're going to drop down everything else. Okay? And then we're going to factor by grouping. And I wanted to group these two together because I can take 2 out of both of those. And I wanted to group these two together because I could take 3 out of both of those. And we'll see if this works out. So I'm going to take a 2x out of the first group and be left with x plus 3. And I'm going to, well, not a 3, we're going to take 9 out of these, sorry. And then plus 9 out of those and get x plus 3. And the good news is we've got 2x plus 3 as we factored by grouping. So our answer here is x plus 3 times 2x plus 9. Same thing we got before, but we got there in a more direct route. Okay, so I'll show you that one more time, and just showing you here that when this is not when it's not prime, this is a composite number. It gets even more interesting, because now what are we going to do? Are we going to have 8r times r? Are we going to have 4r times 2r? What do we, you know, there's more options here for the front end. There's also more options for the back end. Is it going to be 5 times 6? Is it going to be 2 times 15? Is it going to be 3 times 10? And this is one where the direct route can be a little bit helpful. So we are going to get a big number by doing that. So I'm going to go 8 times 30, which is going to be 240. But the cool thing about this one is I need two negative numbers that add to give me negative 83. So let's look at that. We've got 80 times 3, which is 240. And if they're both negative, they add to give me negative 83. So I'm going to stick the 80 with the 8. So 8r squared minus 80r minus 3r plus 30. And now we can group. So these two together, we take out an 8r. We're left with r minus 10. And with these two, I'm going to take out a negative 3. R minus 10. And again, we can see that these are the same. So final answer, 8r minus 3 times r minus 10. Now again, you can get there by guessing and checking too. This time the direct route worked pretty well. And it's going to be up to you on which route you want to use. Like I said, I'm going to show you some other methods in the near future that can get us there a little quicker too. But as for now, I want us to get used to using these, because oftentimes even guess and check can get you there pretty quick, as well as the direct route. But you'll have to decide which one you want to use and when, which one is a little bit better to use. So anyway, that is 8-4.